I'm creating this playlist to discuss about linear algebra topics. Linear algebra is used in many fields including physics, engineering, computer science, machine learning and artificial intelligence and so on. It's a branch of mathematics that talks about vectors, matrices, linear transformations, linear equations and so many other things. So this is the form of linear equations. A1 x1 plus a2 x2 up to a n xn equals to b. Right? So here x1, x2 till xn, these are variables. A1, a2 till an, these are coefficients, and b is some number. We'll see few examples of linear equations. Let's say 2x1 plus 3x2 minus 5x3 equals to 14. This is one linear equation. Also 3x plus 4y equals to 7. This is also one linear equation. Here x and y are variables and 3 and 4 are coefficients. But 2x square minus 7 equals to 5. This is not a linear equation because the power of this variable x is 2. It should be always 1 for linear equations. And let's see one more example. Square root of y plus 6 equals to 7. This is also not linear equation because the power of the variable y is half. Now we'll discuss more about linear equations later in one of the videos in this playlist, but now we'll start with the basic building blocks of linear algebra, that is scalars and vectors. Now from a physics student perspective, scalars are a physical quantity that is completely described by its magnitude, like volume, density, speed, energy, mass, time, and so on. Consider this sphere, right? And it has a radius r. So the volume can be calculated as 4 by 3 pi r cube using this formula, which will always be some number, let's say 5.6 cubic meter. So this is the magnitude of this volume, and so this is a scalar. But let's say one more scalar value, that is for temperature. Temperature can be minus 10 degrees Celsius, right? So it's not necessarily positive. So scalars are described by real numbers that are usually but not necessarily positive. Now in physics, a vector is primarily seen as a quantity with both magnitude and direction. Like velocity, it has a direction, where the object is moving, in which direction, and a magnitude, how fast it is moving. So vectors are often drawn as arrows, where the length of the arrow represents the magnitude and the direction of the arrow represents the direction of the vector. And vector has one tail and one head. Head is pointing towards the direction. Now in physics, vectors can move around in space. Consider this is one vector and this is one vector. So as long as these two have same length, same magnitude and same direction, these two are same vector. But this one is not same vector. Not sure about its length, but its direction is definitely not same. Similarly, this one is not same vector because its direction can be same, but the magnitude is not same. In computer science, a vector is a list of numbers. So if you are from a computer science background, or let's say you are data science specialist or data analyst, and you are dealing with individual person's data, then let's say you are collecting height, weight, age of few peoples. So the height of one person can be, let's say, 5.6 feet. Weight can be, let's say, 58 kg. Age can be 30. So this can be represented as a vector or list of numbers like 5.6, 58, 30. Let's say we have one more person whose height is 6 feet, weight is 65 kg, and age is 35. That person can be represented with this vector 6, 65, 35. So here we can understand that the order of the components are very important here. So always the first component will be the heights, second one is weight, and third one is age. In mathematics, a vector is an element of a vector space. So what is a vector space? We'll discuss about vector space in one of the later videos in this playlist. But let's consider vector space is a collection or a set of vectors. And vectors can be represented as arrays or tuples that represent points in space. So in mathematics, basically we are trying to combine both the idea. We can represent vectors as a list of numbers or array of numbers. Consider a vector is 4, 3. We can represent it in this way, and also we can represent it as an arrow pointing to some point in space. And how do we represent vector? We represent vector with a small letter with bold font. Let's say V, or small letter with bold font V, W, let's say A, this is in bold font. Also sometimes it's represented as a small letter with an arrow on top of it. Now consider this is a 2D plane, right? So this is a 2D plane and we have x axis and y axis, and this, in this direction we have positive axis, in this direction we have negative axis, in this direction we have positive y's, in this direction we have negative y's. So how do we represent the vector 4, 3? For that we'll move 4 steps in the positive direction and 3 steps in the positive y direction. We'll reach here, and from the origin we'll connect to that point. So this is the vector 4, 3. So we are starting from the origin 0, 0 and going till that point 4, 3. Let's say one more vector W, that is 3, minus 1, right? For that we'll move 3 steps in the positive x direction, then 1 step in the negative y direction, right? We'll reach here and we'll connect from origin to that point. This is W, 3, minus 1. This is how we represent vectors in mathematics. Now first we'll see how do we add two vectors. Consider this 2D plane. This is the x-axis and this is the y-axis. And we have two vectors. Let's say V is 2, 3 and W is 4, minus 1. We want to add these two vector. Let's first draw the vectors. V is 2, 3 means 2 steps in positive x direction, then 3 steps in the positive y direction. So this is V. W is 4 steps in positive x direction and 1 step in negative y direction. So this is W. Now we want to add these two vectors. How we do this is we move this second vector and place it at the tip of the first vector this way. Now we have already discussed that vectors can move around in space. As long as the magnitude or length and the direction remains same, two vectors will be same. So let's move this vector and place it here. So this is also W. And the resultant vector will be this one, V plus W. Now let's try to understand the intuition behind this. Consider how we add two numbers. Let's say we want to add 2 and 3. How do we add this? From 0, we move 2 steps in positive direction. Then from that point, we move 3 steps in the positive direction again. Then we reach at 5. So 2 plus 3 is 5. Now what is 4 minus 1? For this one, we move from 0 in the positive direction 4 steps, and then from that place we move 1 step in the negative direction. Then we reach at 3. So 4 minus 1 is 3. So we are doing the same thing for this vector addition. So the first vector is 2, 3, right? So we move 2 steps in the positive x direction, then 3 steps in the positive y direction. So after we reached at this point, from here for W vector, we move 4 steps in positive x direction, then 1 step in negative y direction. Then we reached at our target point. So if we just draw a vector from origin to that point, we'll get our V plus W. Now, instead of doing this x update, then y update, then again x update, then y update, what we can do is we can do first all the x updates, then all the y updates. So for the vector v, we will move 2 steps in the positive x direction. Then for vector w, we'll move 4 steps in the positive x direction. Then from that point, for vector v, we'll move 3 steps in the positive y direction. Then for vector w, we'll move 1 step in negative y direction. Then also we'll reach at the same target. So we can write it in this way. If we have a vector v, that is v1, v2, and w, that is w1, w2, then v plus w can be written as v1 plus w1, that is for all the x updates, then v2 plus w2, that is for all the y updates. So we can extend this in n dimension as well. So if we have vector v, that is v1 till vn, and vector w, that is w1 till wn, then v plus w will be v1 plus w1 till vn plus wn. So we can see it that in this way, like v1 plus w1, this is all the x coordinates update. Then v2 plus w2 may be y coordinate update. v3 plus w3 will be z coordinate updates, and vn plus wn will be the last coordinate update, the nth coordinate update. Next is scalar multiplication. So we'll see in 2D plane only first. So let's say we have a vector 2, 3, and we want to multiply it with one scalar lambda, let's say 2, right? So first draw the vector, that is 2, 3 means 2 steps in this direction and 3 steps in positive y direction here. So this is our v. So now when we will be multiplying it with a scalar, the vector will be stretched or squeezed. Right here we are, the scalar is 2, so the vector will be stretched and the length will be increased by 2. Now if lambda is, let's say 0.5, then the vector will be squished. So it will be like this. So lambda v in this case will be this one. This will be the lambda v. Now consider if lambda is -1, in that case the vector will be flipped, right? So this is -1v. If lambda is, let's say, -2, in that case the vector will be flipped first, then stretched, right? It will be like that. This is -2v. So let's see the coordinates of -2v. It is what? This is -4, -6, right? And we can show it that if vector v is v1, v2, then lambda v will be lambda v1, lambda v2. So each of the components will be multiplied by the scalar. Now as vector addition is allowed, vector subtraction also should be allowed. Let's see why. Consider one vector we have, that is v is 2, 3, or let's take v is 4, 3, and we want to subtract w from v, that is 2 minus 1. Now v minus w can be written as v plus minus w, right? And here this minus w is basically we are flipping the vector w. Let's first draw the two vectors. Vector v is 4, 3 means 4 steps in the positive x direction, then 3 steps in the positive y direction. So vector v is this. Vector w is 2 minus 1, is 2 steps in the positive x direction and 1 steps in the negative y direction. So this is vector w. Now what is vector minus w? That means we will flip the vector w, right? So this is minus w. So we want to add this vector v and minus w. How do we add this? We can just move this minus w vector and place it at the tip of the v vector. Let's do that. So this is also minus w, and we are adding this one and this one, right? So our resultant vector will be this one. This is v minus w. So its coordinates is 2, 4. So if we have one vector v, that is v1, v2, and one more vector w, that is w1, w2, then v minus w will be v1 minus w1 and v2 minus w2. So this is uh, x update of v minus x update of w, and here y update of v minus y update of w. So if you want to generalize it for n dimensional vector, we can write for v, where v is v1, v2, vn, and w is w1 till wn, then v minus w will be v1 minus w1, v2 minus w2 till vn minus wn. So I like to think about vector addition and subtraction in this way. Consider you have a vector v pointing in this direction and one more vector w that is pointing in this direction. So you have placed the second vector at the tip of the first one. In that case, v plus w will be here to here. But if you have v pointing in this direction and w pointing in this direction, then this is the first vector v and this is the second vector w. In that case, v minus w will be from here to here, from the tip of the second one to tip of the first one. Now vector in a two-dimensional space. So you have already seen vectors in two-dimensional space, but we'll see few more properties of vectors. Consider one vector will take, the vector is 3, 4, right? And the vector will be 3 steps in the positive x direction and 4 steps in the positive y direction. So the vector will be this one. Now you want to calculate the magnitude or the length of this vector. How do we do this? Let's see this. We are moving 3 steps here, then from here 4 steps, and we are reaching here. If we see, this is a right angle, right? So using Pythagoras theorem, we can just compute the length of this vector is square root of 3 square plus 4 square, which is square root of 9 plus 16, which is square root of 25, which is 5, right? And we write the magnitude of a vector like this, mod of v. Sometimes we call it norm of v, and or let's say we call it magnitude or length of the vector here. So in general, if one vector is v1, v2, then mod of v will be square root of v1 square plus v2 square. Now unit vector is a vector that is having the same direction, but the length or magnitude will be 1. So unit vector in this direction, let's call it d, that will be v divided by mod of v, or we should write it as 1 over mod v multiplied by v, because this is a scalar value and this is the vector. So this is a scalar multiplication. And for this vector here, let's try to write the unit vector. So it will be 1 over 5 multiplied by 3, 4, right? So the vector is 3 by 5, 4 by 5. If we just want to verify this, the length of this unit vector, that will be using this formula, square root of 3 by 5 square plus 4 by 5 square, which is square root of 9 by 25 plus 16 by 25, which is square root of 25 by 25, which is 1. Now vectors in three-dimensional space. Here we have a three-dimensional space. We have x-axis, y-axis, this is the xy plane, and we have one more dimension defined by this z-axis. Consider we have a vector v, that is v1, v2, v3. First, how do we get that vector? We'll move v steps in the x direction, this is v1. Then from there we'll move v2 steps parallel to y direction, so this is v2. And then from there we'll move v3 steps parallel to z direction, so this is v3. And we reached at this target point, and this will be our target v vector. Now you want to calculate the magnitude of this vector. How do we do this? First, let's calculate the magnitude of this one. Let's call it V12. Now, we moved from origin to V1 and then from here parallel to y-axis, right? So, this is 90 degree. We can compute mod of V12 as square root of V1 square plus V2 square. Now, this is the xy plane, and from here, from this point, we are moving parallel to z axis. So, this also should be right angle, right? So, mod of v, the length of v will be square root of v12 square plus this v3 square. We already calculated v12, so that is v1 square plus v2 square, and then we have v3 square. So the magnitude of this vector v in three-dimensional space will be square root of v1 square plus v2 square plus v3 square. So it can be generalized to n dimensions as well. For n-dimensional case, the mod of a vector will be square root of v1 square plus v2 square up to vn square. Now, unit vector, consider the unit vector is d, and that will be v divided by mod of v, or we should write it as 1 over mod v multiplied by v. Let's consider for this three-dimensional vector only. The unit vector will be 1 over square root of v1 square plus v2 square plus v3 square multiplied by v1, v2, v3, this vector. So if we try to verify, we'll find out that length of this vector will be 1. So this is unit vector. If you find this video useful, please like, subscribe, and let me know about your feedbacks in the comment section.